Okay, so what I'm showing you here is a technology platform that we call Superflex, and what it is a set of component technologies for wearable robotics. What we like to try to do when we're describing it is actually avoid all reference to things like robots and exoskeletons, because we're really designing things that are really lightweight and conformal to the body, and we use terms like exomuscles and exotendons instead of exoskeletons. And the idea here is to be able to add strength around the joints in a comfortable way to help reduce fatigue for the wearers. And our initial goal was to reduce fatigue for soldiers carrying heavy backpacks, but we now have a set of components that can be used for mobility assistance for the older population or people recovering from knee injuries or back surgeries, things like that, and also could be applied for as exosuits for people with a variety of disabilities. For instance, we're working to build a suit for children with muscular dystrophy based on this technology.
So what I see is this person, this model wearing what looks like a wetsuit, and there's some sort of a board here, and then you have a board here, and then if I pan down the cuff, there is something attached which looks like a mic, and it has this netted thing. Is that what you're talking about?
Yeah, so just to point out the components is the key thing that we developed is highly efficient transmissions, motors and transmissions. So this little microphone-shaped device is a motor that can apply 200 pounds of force to your body in something that only weighs a pound. This mesh here is something that we designed specifically to help distribute the load really comfortably across the soft tissue. And then all the electronics that you're pointing out are just the motor controllers, the power supply, and also the sensing that because we are actively sensing the body and controlling the timing of when the motor is working so that it works synergistically with you while you're walking.
So you strap that thing to the back of your calf, and it's 1 pound, you said, but it gives you 200 pounds of energy. What does it give you?
Right, so it's adding 200 pounds of pull to your across your ankle. So your Achilles tendon is pulling across your ankle when you're walking. Your soleus and gastroc muscles are pulling on the Achilles tendon, and so this is basically an auxiliary muscle. It's an exo muscle that's offering you assistance and also helping to add energy across your ankle.
Is this out in the market yet?
So what we're showing you now is the research prototype, and we are actively trying to commercialize this, and we expect to have a company set up sometime later this year to commercialize it.